Okay, so here's number 37. This one was also one that first period struggled with, so I'm thinking that probably everyone has the same questions. And this could be done through u substitution. You could let u equal cosine, and then the derivative would be sine dt, 2 times sine dt, and that would work. But another thing that you can do to kind of shortcut it a little bit is realize that you can change this into the integral of sine of 2t, and this is a shortcut, 2t plus 1 over cosine 2t plus 1 times 1 over cosine. And it's okay for me to write it this way, because if I multiply this expression out, times dt, you're going to notice the top stays at sine, the bottom becomes cosine times cosine, which is cosine squared. And so everything is still equivalent. I just sort of wrote it differently. From pre-calc, you might remember that this expression here, where sine is over cosine, is simply tangent. So that'll be tangent of 2t plus 1. And 1 over cosine is the same as secant. So you should start to see something familiar here. You've got tangent times secant, or secant times tangent, which happens to be the derivative of secant. So if you want to kind of just do shortcut, you can rewrite it this way, and the antiderivative would simply be secant of 2t plus 1. Keeping in mind that when I take this derivative, because of chain rule, I'm going to end up with a times 2 derivative of the inside. So I need to put a 1/2 in order for that times 2 to go away, and just leave me with secant times tangent without the 2. And so I actually did not use a u substitution for this, but I thought it was worth it to go over a different way of doing it. If you had used a u substitution, it'll come out to the same thing, but this is kind of a neat way of approaching it. So hopefully it made sense.